Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. Today, we are going to do the very last problem, problem number 228 on page number 185. Please turn to page 185. Today is our lesson number 256, problem number 228. Problem number 229, number 229 and number 230 were already done, are already done. Today is our lesson number 256 on day 255. Yesterday on day 255 yesterday we finished problem number 30, and day before yesterday on day number 254 we did problem number 229 and had skipped 228 out of laziness, you understand? Because it was annoying, so I wanted to leave it until the end. I don't know why. So we're going to do it today. Now here's the deal. So today is technically it's our last day, but actually second last day. You will find out in a second why it's the second last day, even though it's the only problem that is left in the book. Let's read the problem together. Turn to the page number 185 and read the problem with me. It says the right triangle PQR is to be constructed in the XY plane so that the right angle is at point P. So that the right angle is at point P. Line PR is parallel to x-axis. Line PR is parallel to x-axis. So far so good. The x and y coordinates of P, Q and R, x and y coordinates of P, Q and R, we are told, are integers that satisfy the inequality, and they give you two inequalities. Now in the book they tell you that the x coordinate can be anywhere from -4 to 5. Here I have put down -1 to 3. We're going to do a simpler version of this problem first, and then we'll do the problem in the book tomorrow. On day number 257 we'll do the real problem that appears in the book. Similarly, the y coordinates, we are told, can be anywhere from 6 to 16. Instead of dealing with 6 to 16, let's do a simpler version today from 2 to 5. Okay, let's get going. Once we understand this part, then you'll be able to do the one in the book very easily. And that's what you have to do. If a problem gives it a difficulty because it's a bit too complicated, create a simpler version of the problem of your own, and then do that one first and see how it works out. And you will find that most of the time, once you understand the simpler version, then the complicated version is just the same exact thing. It's just it's more elaborate. It's got more details. That's all. It's got more things to worry about. That's all. But the basic concept stays the same. So how many different triangles can we possibly construct under these constraints? The constraint are that the x coordinate of all of these points P, Q and R can never be outside -1 and a +3. The y coordinate can never be outside +3 and +5. They also have to be whole numbers. The right angle has to be a right angle triangle. The right angle must be at point P, and the line PR must be parallel to the x-axis. We have to satisfy all of this constraint. The question now is, given these constraints, how many possible triangles can we construct? Well, let's find out. The very first thing to do is to draw our region that we're going to work in. So I'm going to just do it very quickly, very freehand. So we are told the x can be bit from -1 to +3. So here's our -1, 1, 2, 3. So x can be anywhere from here. Right there is our constraint for the x. We're also told that the y can be anywhere from 2 to 5. So let's put it here, 1, 2. So that's your 2. 3, 4, 5. That's your 5 right here. So this region, this particular region, we are not allowed to go outside this region. And the question simply is, how many triangles can you construct in it? Well, let's start with point P. Here's the solution. Let's begin with point P. The x coordinate of point P can be from -1 to +3. We are told that it can be anywhere from -1 to +3. For example, I'm going to draw a few of them, okay? We're going to draw a few triangles so you can see it as to what the possibilities are. I'm looking for different colors here. Let's take out the blue, the red, the purple, everything. Everything except the black and the green. See what we can do here. So here's one. Here's one triangle right there. Here's another one. Here's another triangle right there. Here's one more. Here's another triangle. Here's another triangle. Here's one more. Now you understand, depending on how we draw the triangle, we have to make sure that the PR is parallel to x-axis. So in this triangle, this could be PR. In this one, this would be PR. In this one, this would be PR, and so on and so forth. We name our thing in such a way that the line PR is always parallel to the x-axis. And this is the right angle triangle. You see, the right angle is at point P. Right angle is always at point P. Oh, this one does not satisfy. See, right angle at point P. So here, see, I made a mistake. It cannot be PR because right angle has to be at point P. So I have to change the name. Instead of R, this has to be P. Instead of P, instead of this has to be R. And so for so PR, this is parallel. Again, this has to be changed name because this has to be R. This has to be P because right angle has to be at point P. PR. Right angle is right here. There you go. Are there infinite possibilities? How many triangles can we possibly make? There are not infinite possibilities. There would have been infinite possibilities. The possibilities would have been infinite had they not put one little tiny condition on it. This one little tiny condition limits our domain, limits our, I use domain in a very loose term here, limits our universe in a drastic manner because of the fact that these have to be whole numbers. So what could be the x-coordinate of point P? You haven't told me that yet. X-coordinate of point P can be anywhere from -1 to +3. You see, it could be right here, it could be there. So in other words, it can be -1, it could be 0, it could be +1, it could be +2, it could be +3, and that's it. There are only 5 possibilities. Because of the fact that they have to be whole numbers, there are only 5 possibilities that what could be the x-coordinate of point P. Let's make a note of it. 5 possibilities. Now let's talk about the y-coordinate. Y-coordinate of point P can be what? We are told that the y-coordinate has to be from +2 to -5. It can be y-coordinate of point P can be from +2 to +5. Now, as always, as I remind you, it may take 20 minutes to actually do the problem, but once you understand the concept and once you understand how it's done, next time around it should go very fast. It's a very simple thing. It's not a complicated problem once you begin to understand it, obviously. So, from +2 to +5, we have how many choices? It can be +2, it can be +3, it could be +4, or it could be +5. There's only 4 possibilities that we can put the y-coordinates of point P. In other words, where we locate point P is up to us, but there are only 20 possibilities. There are only 20 possibilities because of the fact that it goes from -1 to +3 and +2 to +5. So think of this as a grid system. Think of this as a grid system. It begins at the bottom at 2, it goes up to 5, and then here it goes from -1. From here it goes up to -1 to +3. And -1 to +3, we found out that there are 5 of them, so that's 1, 2, 3, 4, 1, 2, 3, 4, and that's the 5. And then 1, 2, 3, and 4. You see there are 20 possibilities. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why am I getting 25? What did I do wrong? We have 4 for y here. 1, 2, 3, 4. That's my problem. We have 5 here. Y can be only +2, +3, +4, +5. I have 1 too many. I have 1 too many for the y. 2, 3, 4, and 5. Y can only be from 2 to 5. And x can be from -1 to 0 to 1 to 2, 3. So there, as you can see, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. As you can see, there are only 20 possibilities where point P can be placed. Point P can be placed at 20 different locations. That's it. Let's move on to point Q. We're done with point P. Point P can be placed at 20 different locations. Where should we make a note here? P can be placed at 20 different locations, as you can see there, which is why I wanted to do a simpler version, because it would be a help for me to show you this grid system that we just did with the domain that they're giving you there, which, because it goes all the way from 6 to 16, and it goes from, in the book it goes from -4 to 5, but concept does not change. It's the same basic concept, it's just in a bigger version. Let's move on to point, we're done with point P, let's move on to point Q. Let's deal with point Q. What about point Q? Well, this is our P, right here is our P here. This must be Q, because P to R has to be parallel. You see right here, if this is P and P to R has to be parallel to x-axis, then this must be point Q. This has to be point Q, because the right angle has to be at point P. You have to understand all of that. Now on the other hand, if your triangle look like this, nothing would have changed. P to R has to be parallel, so this has to be R. This cannot be P, because the right angle has to be at point P. This is your right angle, and this must be your point Q. The bottom line is that as soon as you fix point P, as soon as you pick one of these 20 choices for point P, for example, if you pick this for point P, then the x coordinate of Q is also fixed. Once you pick point P, the x coordinate of point Q is also going to be fixed. You see, once I fix this point, we have to come straight down, because it's parallel to y-axis. PQ is parallel to y-axis. Now, how do we know that line PQ is parallel to y-axis? Because of two things that we are told. Because of the fact that we are told that the line PR is parallel to x-axis and it makes a 90-degree angle. Well, if the line is parallel to x-axis and it makes a 90-degree angle at point P, then the line PQ must be parallel to y-axis, because it's a right angle triangle. Therefore, once the point P is fixed, so is the x coordinate of Q. So is the x coordinate, for Christ's sake, of Q. And what about y coordinate? The y coordinate of Q can be any of the remaining 3 points. Let's understand this part. So once you pick point P, the x coordinate of point Q is already fixed. The y coordinate of point Q, how many choices do we have for y coordinate? For y coordinate we had this from +2, 2, 3, 4, 5. There are only 4 choices that we had to begin with. We have already used one of those y coordinates for point P. So obviously point Q cannot have the same y coordinate, obviously, because otherwise point Q will end up falling on, point Q will end up sitting right on point P. We won't have the triangle. So once we've chosen point P, we have used up one of the y coordinates. Out of the 4 possibilities, 2, 3, 4, 5, we have used up 1 for P, which means there are only 3 possibilities for Q. Let's make a note. Point Q can be at 3 different locations. Point Q at 3 different locations. Let's move on to point R. Let's move on to point R. Now when we go to point R, exact opposite thing will have happened here. Once we chosen point P, the x coordinate of point Q was fixed. When we talk about point R, once we have chosen the point P, because of the fact that P to R is a straight line parallel to x-axis, P to R is parallel to x-axis, therefore once you choose the point P, we have already determined the y coordinate of point R. Once point P is chosen, so is the y coordinate of R. So is the y coordinate of R. The x coordinate of point R can be any of the remaining, well, how many choices did we have for x coordinate? Let's count them. -1, 0, 1, 2, 3. We have 5 choices to begin with. We have already used one of those 5 choices for point P. We have only 4 choices left. That's it, we are done. The problem is done. So let's make a note here. I'm going to erase this part now. Remember, P was 20, Q was 3. Let's make a note here. P was 20, Q was 3, and we just found out that the R is 4. Voila, that's it. That's our answer. How many different triangles can you construct? The answer is 4 times 3 is 12, 12 times 2 is 24. 240 different triangles can be constructed. 200, there are 240 possible triangles that can be constructed given the constraint that the x and y coordinates of point P, Q, R have to be integers. The x and y coordinate must lie between -1 and +3. The y coordinate must lie between +2 and +5. Line PR must be parallel to x-axis, and the right angle must be at point P. Given all of these constraints, there are only 240 triangles that can be constructed. That's it, we're done. What I want you to do now is do the exact same problem, do the problem that appears in the book. It's the exact same thinking, exact same logic. I want you to try the problem yourself first. I could very easily continue and get that out of the way too, but I don't want to do that. I want you to try the problem number 228 on your own using the same exact logic, same exact system, and see if you can come up with the answer there. And then if you wish, you can watch the next video, day number 257, to compare your work against the work that you and I will do together, okay, in the next video. Bye now.